Test on Monday. I have something really different. Everybody's got something going on. I'm just done. So Monday, I don't. If you have something that's conflicting, I don't care anymore. I'm done. It's Monday. Period. All right. Would you try? This is actually something we've done recently, so it should just take a second. Today's lesson is a lot of rational function graphing and integrating. So, why do I have to divide this first? Because the power is equal on the top or greater. All right, so I have to divide. Can I synthetically divide here? You cannot. So you will first long divide and then integrate. So would you try that long division style? See if you are getting that. That'll be on the test on Monday. See if that's something that's doable. We did that a lot in set 75 or 6 extra practice. I can't remember what. 77. Okay, did you get that the equivalent integrand is 2 plus 1 over x squared plus 1? If not, actually, did I get, I have an x, don't I?
Yeah.
Okay. So an x plus 1 over x squared plus 1, yay? Okay, cool. All right, so 2 obviously is easy enough to integrate. How will I integrate x plus 1 over x squared plus 1? Okay, you're both kind of right after step. You said I heard inverse tangent, I heard u sub, and they're both right, but only if you split them. You cannot integrate the way it is. It cannot be integrated the way it is. It must be split into x over x squared plus 1 and 1 over x squared plus 1. All right, now, if I u sub the first one, what's u? X squared plus 1, therefore du is 2x dx, so we've moved the 2 over, and it becomes 1/2 du over u. We? And so eventually 1/2 natural log of the absolute value of x squared plus 1. We? All right, what about the antiderivative of 1 over x squared plus 1? R tangent. Okay. A lot of integration skill in there to be seen or measured. All right, cool. Let's go on to the other idea. This is typically more of a pre-calc idea, but it's not taught in ours in the green book like it should be, so it's coming now. So rational functions, you know all the vertical asymptote and whole stuff. That's not going to change. It'll be the other behavior that's going to be different here. You'll see, okay? So getting into this, first we factor it. And when we do, we get something like that. Now, remind me the big idea. How do you know if you have a hole in the graph or not? You have a common 0 in the numerator and denominator, yeah? How do you find the location of the hole? Obviously, the x of the hole is at 0. What's the y of the hole? Yeah, plug it into the rest, so the hole would be at 0 and -4/5. We? Okay, so far I've graphed where the graph isn't. 0, -4/5. I have a point where the graph is not. Awesome. Numerator, to find the y, we got that. What happens when the numerator is 0? Remove the holes. When the numerator is 0, what's going on graphically? X-intercept. Okay, so I have an x-intercept at 4. And when the denominator is 0, what's going on? A vertical asymptote. Okay, so we have a vertical asymptote at 5. All right, cool. Now, the new stuff for the day is going to be, instead of always going to the x-axis like you did in the green book, you're going to actually have one of three cases. Now that you know limits, it's not that hard. Think end behavior. Do you agree that the powers, top and bottom, are equal? So in this case, the limit as x goes to infinity of x squared minus 4x over 5x minus x squared is -1. What does that apply graphically? Well, as x goes to infinity, y goes to -1. That's what the limit is. It's what the y values approach. So out here, I can say that the graph must approach -infinity. Now, generally speaking, the limits will be the same on both sides, plus and minus, positive and negative infinity. I want you to be aware that sometimes they can be different. In this case, you'll see that both on the left and the right, y approaches -1. We?
Yes.
Alrighty. So, graphing-wise, then, let's talk about this graph. We could do a sign test here. If I tried all the region left of 4, would I get positive or negative? These guys will wash out, do you agree? No matter what I choose, so they're going to cancel out. So I'd get a negative over a positive, which is an overall negative, yay? That makes sense because I expect to pass that asymptote. I expect to pass through that hole until I get to 4. When I get to 4 and pass 4, now the top is bigger, and 5 minus 4.5 is positive, so those are both positive. The graph will go like that. And then what do you reckon past 5? Greater than 5, you get positives or negatives? Negatives. Here or here? Second one. Yeah, obviously it doesn't have a 0. It doesn't go positive. It has to be. You with me? All right, cool. This will be a little more new here. All right, now check this out. This is 4 minus x squared x, or 2 plus x and 2 minus x. Does this have any holes? No. Okay. And does it have any x-intercepts? And if so, where? -2 and 2. Does it have any vertical asymptotes? 0. 2. Okay. Now, get ready to get wacky here. What kind of end behavior does this have? As x gets infinitely large, 4 minus huge over huge, but which one's bigger? What's the end behavior? Goes to negative infinity. So it goes this way. And what about as x goes to negative infinity? It goes to, so that would be 4 minus really, really big divided by negative really, really big, but which one wins? So it'd be negative over negative and positive infinity. Now then, that said, what exactly does it do is the lesson of this day. To find the end behavior, today you will divide. Now, division could go actually one of 3 ways. This way, this is synthetic division, and there's also long division. The easiest way to divide this is just to separate negative x squared over x plus 4 over x. Therefore, y is negative x plus 4 over x is the equivalent equation. Do you agree that's the same, yay?
Yes.
Okay, now let's think end behavior. As x goes to infinity, this remainder here goes to, what's 4 divided by infinitely large? 0. That means then the equation approaches just y equals negative x. Now that is a line, obviously, with a slope of negative 1. This is called a slant asymptote. And it goes a little something like this. If you graph y equal negative x, the graph is going to follow that guy as x gets infinitely large. So, for example, out here, let's verify just sign-wise, okay? You'll see it follow that asymptote, and it'll actually make sense if you think of large negatives, negative 10, okay? 2 minus 10 is negative, 2 minus negative 10 is positive, and negative 10. So that's negative, positive, negative, overall positive. So it's going to follow that asymptote. It's not going to do that curvy thing. Got a little shaky there too. Alright? Now that asymptote is for the end behavior only. So as far as now when I switch over here and pass negative 2, maybe say negative 1, okay? What's 2 minus 1? It's just sign-wise. Positive. 2 minus negative 1 is positive over negative 1. Negative. So positive, positive, negative is negative. It'll get smaller and smaller. As x gets smaller and smaller, we're going to get really big negative results because we're going to divide by tiny numbers. That's why it gets negatively huge. You follow? Now we're going to trip over 0. Maybe 1, for example. Positive, positive, positive. 3 positives is positive, and again, as x gets smaller and smaller, as we get closer and closer to an x of 0, dividing by tiny, tiny numbers makes for big results. And then finally, we're going to switch signs again at 5, something like that. Positive, negative, positive is 1 negative. It's going to be negative, and you'll see it follow that asymptote. All right? Are you with me? All right, that is what graph with the slant asymptote looks like. Let's try one that you have to do a little more division work for. This one, because it was just an x in the bottom, I could split it up individually over each x. This one, there's a little more going on. It's not just x in the denominator, so I'm going to need to divide. I'll do that in a minute. First, let's talk zeros and holes and vertical asymptotes. Any holes? No. Any x-intercepts? Why not? There are no real zeros to x squared plus 2. Do you agree? X squared plus 2 is always positive. All right, so that's number 0. Now let's take imaginary roots. Is there a vertical asymptote? At what? X equal negative 1 is a vertical asymptote. Remember when I asked you for asymptotes, give me a whole equation. Negative 1 is not an asymptote. X equals negative 1 is an asymptote. Now, as far as the end behavior, I'm going to synthetically divide here because I have just a linear equation in the divisor. So I'm going to put a negative 1 as the 0 in the box, and the coefficient line, don't forget your placeholders, is 1x squared, no x's, and 2. When I divide, I bring down the 1, multiply, and record it in the next, and add. Multiply, record it in the next, and add. Interpreting that, then, this divided out is equivalent to, what does this tell me? This is equivalent to? Okay. Now, in terms of graphing then, again, remember the remainder idea. I'm looking for end behavior. And for end behavior, the remainder gets to be less and less. For x to the, when x is a billion, this remainder doesn't mean jack. You with me? And so the graph starts to approach just y equals x minus 1. This part is the slant. So if you find a y-intercept of negative 1 and then go a slope of up 1 over 1, then we get a graph like this. Okay? Now, first time through, first couple days, it's very common that I'll see just stuff that's just totally, if you think about it, just total nonsense. So I'll have somebody that gives me this. Why does that student have no idea what they're doing? Okay, first of all, that's not a function. There's no zeros, okay? So you're telling me that when I put x equals -3 into this equation, I get two different results? No, I don't. I get one. Okay, so this is a function. It better pass the vertical line test. Don't just go, I know it's supposed to be in some, I'll just put some in every quadrant. That really, I'll throw crap everywhere. Okay, just, come on. Okay, it's got to be, in terms of where it is, here, it's on this side of this asymptote, it's got to be a function. Over here, it's a function. So it's either got to be here or here. It cannot be both. It's a function, vertical line test, all right? So the question then is, if it's below -1, what do we get, positive or negative? The top is always positive. So the bottom would be negative. So I get a negative, and so where should I put it? Down here or up here? Down there. Also, the fact that I have no x-intercept tells me I kind of have to be up there. All right. What about up, or sorry, down here. Excuse me, I said up here, but I meant down here. Above x equal -1. Top is positive. Now the bottom is positive. So the graph must be in there. I like that. All right. It does look kind of cool. Alrighty. Now let's get into a little grosser one. This guy has a non-linear divisor, more of a quadratic divisor, so now we have to long divide to find the slant. But before we do that, let's find the basic stuff first. Factor completely so that we know all the inside junk, the holes and the vertical asymptotes and the x-intercepts. We'd have x times x minus 2 times x plus 2 over what in the denominator? X plus 3. X plus 3, x minus 1. Does this graph have any holes? No. It does not. Does it have? Where does it have x-intercepts? 0, 2, and -2. Where does it have vertical asymptotes? -3 and +1. Yeah. Right? Okay. Now, we're ready for the end behavior. We're going to divide. Actually, you could technically divide twice synthetically by this. I don't like to do that. I would prefer to multiply. X squared plus 2x minus 3 into x cubed, no x squared, minus 4x plus 0. Right? So, how many times does x squared go into x cubed? X times. Multiply x cubed plus 2x squared minus 3x. I subtract that, so I change signs. Draw the line. X cubed minus x cubed is 0. Negative 2x squared, negative x, and down the next term. So, are you looking at negative 2x squared minus x, right? All right. X squared goes into negative 2x squared. How many times? Negative 2 times. Negative 2x squared minus 4x plus 6, but change signs. Draw the line. 2x squared minus x squared. 2x squared goes away. Negative x plus 4x is 3x minus 6. Therefore, my equivalent equation is x minus 2 plus 3x minus 6 over x squared plus 2x minus 3. Are you with me? Yes. All right, so just so we're clear, when we divide, when we were integrating, like our first example, that remainder, we worked with that remainder. We needed that remainder. Do you agree? We had to integrate the remainder. Remember? Way back. This one, remember how that remainder, we actually dealt with it, we needed it? On these slant asymptotes, the remainder is a non-issue. We don't care about the remainder. We're more talking in this case, as x gets infinitely large, the remainder will go to 0. So I dump the remainder here, and I just say y equals x minus 2 is the slant asymptote. You follow? Y equals x minus 2 then has a y-intercept of -2 and a slope of up 1 over 1. And so now we have a lot of sections. In terms of the sections, think more like the number line of x. So we don't get into, 1, 2, 3, 4. We don't do it. Just do these. Did I make a mistake?
Yeah, it does.
Oh, sorry, I did a bad slope. Good call, thank you. I graphed my asymptote backwards. Okay, all right. Don't worry about that. Again, the asymptote is really end behavior, so don't worry about inside. It's just a guide for the outside. Obviously, the remainder only goes away when we're talking infinitely large x's. For little x's, that remainder is very much in play. You with me? So the end behavior is the slant asymptote. So don't sweat crossing that slant asymptote in here. It's another issue. All right, now then, when you go to figure out where, you're just looking along the number line at all the different x scenarios, okay? So when I go x less than -3, -5 maybe, negative, 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 5 negatives, and that is negative. And so if it's negative and following these asymptotes, it's probably down there, okay? All right, now I went over -5, but before I went over -3, but now I'm before -2, so maybe -2.5. Negative, 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 but now this one is positive, negative. So I have 4 negatives, that's positive. So I'm going to follow that vertical asymptote till I get to that x-intercept. Now I'm going to trip over -2 and get to maybe, I'll try -1. Negative, negative, positive, positive, negative. That's 3 negatives. So negative. I need to go up until I get to that next x-intercept at 0, or at the origin. Now I'll try maybe a half. Positive, negative, positive, positive, negative. I did that so fast I don't even know what you said. Positive, positive, negative, positive, positive, negative. That's 2 negatives, so positive. And then on the other side of 1, but before 2, 1.5. Positive, negative, positive, positive, positive. 1 negative is negative. And then I'll switch signs and follow this one. So it looks something like that. Yeah? Class ends at 6:59. But tomorrow's an ends day, so we can get caught up with so we can get through all the questions. All right. You try one, please.
Does that go above or below?
Good question. Does this go above or below the asymptote? Is that what your question was?
Yeah.
Okay. It doesn't matter if it's above or below or on top of, but I can tell you that looking at the remainder, when x is above 3, this remainder is positive. Or is it negative? No, it's positive, okay? So it actually should ride just a little above the line, but nobody would know it for that. Okay? Take attendance. Okay. Miss Brown, will you be Thursday? Are you going to be here Thursday? Will you be here tomorrow? I'll try and get through some of that stuff. Are you excited? You guys ready?
Yep.
I'm excited. All right. Tuesday. Thanks. At okay. All right. What did you get for a slant asymptote? Y equals X. All right, good. All right, and then graphically, I would say something like is that what you have? Excellent. Yes.
How do you know if you synthetically divide it or not?
So if you synthetically divide it, this has linear divisors, but it has two of them. So let me show you, it's called repeated synthetic division.
Oh, yeah.
You would have to first divide by -1,
Yeah.
1, 0, -4, 0, 1, -1, -1, 1, -3, 3. Then you would have to divide that by +1.
Okay. Oh, yeah. No.
0, 0, -3. So it'd be something like y equals x. Okay? Okay. All right. That's not how I was taught. I'm okay with it. That's not how I was taught. All right. That's it, right? Is that the last example? Okay. Would you at least get out your homework and check your answers and see how you did with this? Hopefully you are doing well. Number 1 is B. With work, obviously. 2 is D. I already typed my answers. They're in a different order. It's D. Sorry, I made some formatting changes and then made slides for my new slide. It's, look in the folder below those papers. Sorry. Okay, are we cool? 3. Your answer is A. 4, not 4, whatever the next one is. A was 7/2. B is 16. Oh, sorry. I is 16. I is 36. Am I missing a piece here?
Yeah, there's a C and a D.
C is 4. D is 4. D is -5/2. Did we get that? All right. 5. Both ways you should get, through different methods, you should get the same thing. -e to the -t plus 3 plus 1 over e. And 6 was kind of gross. You had to be on your force game there. Sorry, part of it was my fault. Assume water. Sorry, I neglected to say what it was. If it's water, then it's 207.2797. All right. Questions? We have about 5-6 minutes. I can get through a question or two. We can finish tomorrow. What do you got? 6. Yep. It is joules, not newtons. You're right. Thank you. Joules. 6A on the graph. A on the S graph. Let's call that, I think I intended that to be number 4. Okay, so we'll call it 4. All right? C and what?
C and 5.
C and 5. Okay? All right. Like I said, we'll get through all we can and finish tomorrow. Tomorrow's another ends day, so we can get plenty of questions answered tomorrow. I'd rather you just understand. So, here we go. Let's start 6. I did not say where you had to put the origin, but where did you put the origin? At the top or the bottom? Excellent. Okay. So this is 0.5, this is 0.5. That means this would be 0.25 and 0.25. At that point, I wasn't having too much of an issue. The height is at 0.1. That also is clean. All right, so everything was going swimmingly other than the failure to give the fluid. Rho, distance, volume, 9,800. Let's talk limits. They're not too hard. What are the limits? 0 to 0.1. That was easy enough. Then the hard part, the distance. Do I need 0.1 for the distance, or do I need the top of the container? Top of the container. All right, so let's talk equilateral triangle. The base equilateral triangle in geometry is considered a 2, 2, 2 equilateral triangle. Now, why 2? So that when you split it, it's a 1, 2, root 3. Are you with? Okay, now, talk to me. We could do this by trigonometry or by geometry and scale factors. What's the scale factor to take 2 down to a half? A 1/4 scale factor. So, if I take this by a 1/4 scale factor, how long is that? What's the height? Root 3 over 4. The height is root 3 over 4. Okay? You could also, like I said, do it by 30, 60, 90, SOHCAHTOA kind of stuff. You have so many. I assume if you had trouble, it's because you couldn't decide between all your different methods. What is the distance then you must pump to get to the top of the container? Root 3 over 4 minus 1. All right. Now the volume. The volume is the volume of these sheets here. They are length, width, and height. The width is, or the length is 10. The width, constant x or 2x? 2x's, and the height is dy. All right, so now the x. What's the slope of that line? Might be easier to look at the slope of this line. Root 3 over 1. So, if the line is y equals root 3 over 1x, then x is y over root 3. All right, so there's 2 of them. So, altogether then, the volume, length, width, and height is 10 by 2 by y over root 3 dy. Right? And assuming I put it in the calculator correctly, that's where I got it. All right. Shall we go to 4? Hey. Okie dokie. So, do I have, I have the picture there somewhere. All right. Okay. Here we go. Are you ready? So 4A, your issue might have been, does the discontinuity affect? And technically, we haven't done discontinuous integrals, but the answer is no, it doesn't. If you take left or right hand infinite rectangles, it approaches the same value. So don't sweat the discontinuity. I just did trapezoid plus triangle. So for the trapezoid, what's the base 1 and base 2? Base 1 is 3, base 2 is 2. What's the height? 1 divided by 2. For the little triangle, what's the base, what's the height? Base is 1, height is 2, divided by 2, yay. So I get 5 halves plus 2 halves is 7 halves.
So why does that mean that it doesn't exist?
Why it doesn't exist, don't worry. I guess they're trying to bait you into thinking, oh, you can't do it because of the discontinuity. Okay?
It says error explained.
All right. The rest will finish tomorrow. Have a nice, you do not have to turn this in. I guess nothing to do today, correct?
Yeah.
Okay, so, that's right. I'll get it to you tomorrow. Have a lovely day.
I didn't say.
I'll give you a 5-minute spiel of classes. I don't know what you're choosing, but I just want to talk. For seniors too. Credit tomorrow. Have a nice day, people. Yes. This should be, I have a nice day. That should be root 3 over 4 minus 1.
Oh, okay. So total. Thank you.
Okay, hi.
I was wondering how I did on the AP test. If we had
You did pretty well. You can look at that. I did pretty good.
I got a 6 out of 9.
Good baseline. All right. Thank you. All right. So let me see. So
I'm just gonna put my stuff down.
sure, that's fine. No problem. All right.
Department Manager, are you going to schedule us an additional meeting next week?
Apparently
we
still
blew it today.
birthdays, yeah, I guess so. Yeah, I don't know whether we should do it at lunch or after school. I don't even, do we have a staff meeting next Tuesday?
I haven't looked at that. We don't have another, we might. We don't have another interview. We won't have an interview committee meeting until the 18th because it gets posted on the 10th.
Okay.
And it's open for a week, so there's no way we can do anything on the 11th. But yeah, that's a good question, whether we have a staff meeting or not.
Okay,
Go look
I'll
at
look
my
up,
calendar.
I'll look it up by the meeting and we'll talk about either lunch or after school depending on the meeting.
Sounds good.
Okay, thank
Thank
you.
you.
All right.
I'm pretty sure we do not. Isn't it on Friday, the 14th? The work day
Oh.
that we have next week?
Is there a meeting on that day? You
I'm
probably
pretty sure
have
there's
to-
one that morning.
Okay. Okay, then maybe we're good and we'll do it.
Either way.
Okay. All right.